Alright guys, today we're going to do rotations. Again, this is a fairly easy one. There are some more complicated parts of rotations, but we're going to do those after topic 11 when we learn constructions. I don't want to bog you down with I'm not going to say complicated parts of the course, but it is very new to most of you using these tools to construct things. I want your background knowledge to be solid before we jump into trying to use the tools to actually do the construction. So what you do have in front of you is your bell work, and this is what I expect you to turn in today before you leave. Whoever our guest teacher is, just hand it to him. I left him directions to separate them by block and leave them on my desk. Anywhere along this that I ask you to do participation, you're going to put that on your sheet as well and hand it in before you leave. This is not going to be a hard one to do. You can see on the bottom left corner, we only have 9 slides today, and you have an hour and a half in class. You should be able to finish the homework. The homework admittedly is slightly longer than average, but that's just because this is such a short lesson. I want to make sure you get practice with this, because you have a quiz on Friday that covers this, translations, and reflections. And then Monday we're going to finish the topic, and we are done with all the material we had to cover for quarter 1. So you should have a test probably on I think it's the 11th. Don't hold me to it. I will put it up on the board. Yeah, we're done with topic 3 now. We're moving right along to topic 4. So I'll go ahead and pause the video now if you haven't already solved this problem. You're translating it. Your x value is -3, your y value is 2. You're taking triangle SBK, and you're going to find the coordinates of triangle S prime, B prime, K prime. S, B, and K are the pre-image coordinates are listed below. Alright, so we're finally on the little r, the only one that we're going to do that uses a lowercase letter in this chapter. So this is read as the rotation of triangle X, Y, Z 75 degrees around point P. Again, the rotation of triangle X, Y, Z 75 degrees around P. Now, this may be new to you. There's positive rotation and there's negative rotation. Alright, again, rotations, as we said earlier, are rigid motions. Positive rotation is counterclockwise. So if you look up at the clock right now, you'll notice that the hands go in this direction. This is called clockwise. Counterclockwise is in the opposite direction. This is counterclockwise. Oh, why did you stop working on me again? Alright, so for some reason my tablet's not working past this point. So, counter. Clockwise. Clockwise rotation is negative, and counterclockwise rotation is positive. So when you're on the test and it says rotate it in a positive, or use a positive rotation of 90 degrees, look up at the clock and remember positive is in the opposite direction of the way that the hands move. Negative rotation is the direction in which the hands on the clock move. The easiest way to remember it is what you're used to seeing is negative, and what you're not used to, or the opposite of what you're used to seeing, is positive. So positive goes from 12 to 11 to 10 to 9, 8, 7, 6, 5, 4, 3, 2, 1. That's positive rotation. And if you go around the way the clock goes, that is negative rotation. Now let's see if we can make it through this whole PowerPoint without needing all that space. All right. The image of P is equal to P prime. And what that's really saying is, if we look here, we're rotating about the point P, this point X, Y, Z are rotating 75 degrees, so that's positive 75. So we're going to go anti or counterclockwise, so we're going to go this way 75 degrees. Now, because rigid motions, we must use every point given to us, so we're going to use X, Y, and Z. This is going to rotate this way. Now point P, that's that fixed point of rotation. We're also going to get P prime here, P double prime, P triple prime. Every time we rotate this figure, our point P in which it's rotating about will also increase in its prime notation. It doesn't move, just like if the line was on the line, or the point was on the line of reflection, it doesn't move. We said if, let's do a new one. So if we had a point A, and I said reflect over line P. So if I have reflect over line P, the point A, well, A is 0 units from P, so I also have A prime. Same thing here if I have point, well, let's not do that. Let's get rid of this. Now if I have point P and I have point A and I say rotate negative 90 degrees around P, the point, and I run out of room and it won't let me go either direction. All right, A. Sorry that looks so bad. That's rotate negative 90 degrees around point P, the point A. Negative 90 degrees is going to be clockwise. And since I'm at noon, right, if this was a clock, this would be at noon or 12. I'm going to come over to about 3 p.m. If I were now if I take point A prime and I say rotate it 180 degrees around P for A prime. So 180 degrees positive is in the opposite direction. Let's change the color here. So I'm going to do A prime in red. Or sorry, A double prime in red. So I'm going to go 180 degrees. There's 90. Here's 180. Now, had I made this negative 180, negative 180 is clockwise, and it would land in the same point. A rotation of 180 degrees is equal to a rotation of negative 180 degrees. So any multiple of 180 degrees plus or minus maps to the same point. Simply put, I can rotate positive or negative 180, 360, 540, 720. Any of those degrees, and the positive or the negative will map me to the same point, much like reflecting a point across the line that it rests on. Alright, so you'll see that rotations are much easier in a coordinate plane than they are constructed. Of course, you haven't really seen it constructed yet. I'm not there. Trying to show you or teach you how to construct a rotation without a coordinate plane would not just be very difficult, it would be frustrating, and it wouldn't be worth your time to kind of have to try and fight through that idea. So nothing on your quiz or test is going to test your ability to rotate off of a coordinate plane, so we're kind of focusing on the coordinate plane here today. You saw that reflecting was easier on a coordinate plane. Same rules applied on a coordinate plane. The distance from the line of reflection to the image had to be equal to the distance from the line of reflection to the pre-image. Translating, even though we push people around the room, threw items back and forth, all that, got to see translations in the real world. Trying to do a translation without a coordinate plane really is difficult to imagine. may even be impossible without a ruler or some measuring device to make sure that we understand where it's going, where it's heading. So rotations are pretty easy to understand as well. Before we really talk about this, I want to show you kind of what it means. So let's say we have a point P, and we have point A. All right. A starting point would be 0 degrees, right? It hasn't moved. There's no rotation here. It's at 0 degrees. If I move it in a positive 90, I'll go from what is essentially 3 o'clock to 12 o'clock, and that is a positive 90 degrees. From there, if I move another 90 degrees, oh, you know what I didn't do? Didn't show you that this is my first move. Now, once I move here, I am at a double prime. 90, so 0 plus 90 is 90. 90 plus 90 is 180. So far I've moved 180 degrees. Just like you saw here, well, we'll do that in a minute. From 180, if I move another 90, that'll put me in the 6 o'clock position for a triple prime, and that is 270 degrees. So I have a 0 degree position, a 90 degree position, a 180 degree position, and a 270 degree position. If I were to add another 90 degrees in a positive rotation, I go from 270 to 360, but look where I land. Right back where I was. So this is going to be comma 360 degrees. Now I can add another 90. This would be 450, but that's my fourth movement. So I have A to the fourth, and that's 360. So I have A 0 degrees and A to the fourth, or A fourth prime is 360 degrees. So those are the major points. Of course, right in between 90 and 0 is 45 degrees, 135, 225, right? Yeah. And 315 degrees. That would be 315 degrees right in the middle of these 2 points. Now, one major mistake I've made, and that's not so much a mistake as what I haven't actually shown you, which I did mention was very important earlier, is every time I rotate a point, I also have to consider that P went from the pre-image to an image. So I really have P prime, I have P double prime. That was created when I went here. When I went here, I created a triple prime, and P has rotated 3 times. And of course, when I came back all the way around, I have my P to the fourth. So if I'm properly labeling all of this, I do include my P prime, P double prime, P triple prime, and P fourth prime, because that P has moved 4 times. It just appears in the same position, but its orientation, or the direction that it's pointing, has moved along with my A as it's gone around. Now, that's in the positive, everything I've just showed you. Let's look at something in the negative really quick, and I'm going to use red. Let's say we associate red with negative. So we're going to stick with red. I'm going to make my brush size just a tiny bit bigger. All right. So if I started at A, which was 0 degrees, and I go negative 180. So remember, negative rotation is clockwise. So I'm going to go from point A right here, negative 180 degrees. So here to here is negative 90, and from here to here puts me at negative 180. And if I kept going around, it would be at negative 270 and then negative 360. You can see here that negative 180 and 180 land on the same point, and then negative 360 and 360 also land on the same point. That's why I said earlier, multiples of 180 can be positive or negative, will land at the same point. Is that particularly helpful in solving these problems? No. But if you've already done the work and you can show me, like I did in this example, that a double prime is at 180 degrees, let's say from a to the fourth at 360 degrees, I asked you then to rotate negative 180 degrees around point P, the point A to the fourth. That's what I've done in red. Now, you'll see a double prime was at 180 degrees positive, whereas a to the fifth, right, because that's what this would ultimately be, will now be in the exact same point. So now let's look at these. We have the rotation of 90 degrees about the point O, the rotation of 180 degrees about the point O, and the rotation of 270 degrees about the point O. So what I'm going to do, I'm going to split screen this. All right. So here's my point O, and I am going to take XY, and let's say that XY, or my point A, is at, what's a reasonable thing there? 1, 2, 3. Let's say it's at 3, 4. If I were to ask you to rotate point A 90 degrees about O, I would change my X and Y order, and then I would negate my Y. What does that mean? So I have this is my original X, this is my original Y. Maybe I should have done this with 1, 0, or 0, 1, or 1, 1. No, 1, 1 would be weird. Okay, so what I'm going to do is I'm going to, for 90 degrees, what I really want is negative Y comma X. Here's my Y, so I'm going to bring it over here. It's going to go down as negative 4. And then my X will come over here and stay the same. So if this is at the point 0, 0, or the origin, negative 4, 3 would be about 1, 2, 3, 4. 1, 2, 3. Now 180, I keep my X and Y in the same order, but I negate them both. So here again, well, this is A prime. Let's change the color. For A double prime, I go back to my original X and Y. So (180 degrees), I just negate them both. Negative 3, negative 4. So that's the same as going 1, 2, 3, 1, 2, 3, 4. Here's my A double. Now, what you'll notice here, even though I'm not on a coordinate plane, you can kind of see I'm basing my positions off of a coordinate plane. From A to my point of rotation to my 180 degree rotation creates a straight line. That will always happen when we do this. And then, if you think about it, a little thing that's kind of easy. My last one is 270 degrees, or I swap my order and negate my X, or what is 270 minus 90? Well, that's 180. So that means this is going to be right on the opposite side. Oh, my eraser doesn't work. Cool. That's the smallest eraser they could have given me. Now, that should just be 3 marks. Okay. Now let's actually do this on a coordinate plane. So let's say that A is the point 2, 1. And I'm asking you to rotate positive 90 degrees about O point A. O is typically denoted to be the origin. This will be our O. So my A is 2, 1. So I'm going to rotate that 90 degrees in the positive. Positive rotation is in this direction. It's anti-clockwise. Why did I put a C there? So I was saying clockwise. Or counterclockwise, whichever way you say it. I watch enough people or talk to enough people who say it both ways, so it's kind of sinking in where it's interchangeable for me. So to rotate A 90 degrees about 0, I'm going to look at its coordinate, which is 2, 1. I'm going to flip back over my PowerPoint. To do it 90 degrees, I'm going to take my X and Y. I'm going to reverse their order. Right? So now I have YX, and I'm going to negate what I get when I flip. So now I'm going to have -1, 2. So let's look at that. -1, 2 will be A prime. Now, if I want to rotate A prime, so now I've done this, and I'm going to ask you to rotate 90 degrees about O, A prime. New color. So to rotate this 90 degrees again, I have my new point as -1, 2. So I'm going to flip it. I'm going to get -2, -1. So I've taken this point, I've swapped my X and Y, and I negated my Y. So I should be at -2, -1. Now, if you want, let's look at this really quick just so I can show it to you. Here, I have 1, 2, and 1. Okay? Here I have 1, 2, and 1. This is the same as, oh, come on, erase. Oh, I need that point back. So, again, these are straight line across from each other. This is the same as graphing, or reflecting, sorry. Ooh, I missed my mark there. If I were to have asked you to reflect across the line, y equals -x, a, we would have gotten the same thing, right? Same distance, up 1 over 2, down 1 over 2 in the opposite direction. This rotation of 180 degrees is the same as the reflection of y equals -x. And that is what I kind of mentioned earlier, or I'll mention in a minute. Rotations are just a composition of reflections. Translations can be as well. So now I'm going to ask you to rotate 90 degrees. Oh, what letter was this? This is A double prime. What color am I on now? Purple. Rotate 90 degrees about O, A double prime. Well, in blue I have A double prime. So I'm going to swap their order and negate my X. Or what was originally my Y. Change it over and negate it. And I'm at 1, -2. Now look what's happened here. Up 2, left 1, up 2, left 1. A triple prime. That is the rotation of A to 90 degrees 3 times. Now let me just show you one last time that you'll see. What's the color I haven't used? If I rotate this again, if I rotate a triple prime 90 degrees about O, I'm going to swap this over, negate it, and I get 2, 1. So let's see where I am. Here's 2, here's 1. That is A to the 4th prime. So, a couple things to say here. The 4th time, right? The fourth time I've rotated something 90 degrees, I get 360 degrees. That's not a coincidence. It's also not a coincidence that a circle is 360 degrees. And if I were a little better at using this, yeah, that's not a circle, guys. Let's try going in a negative rotation. So I've kind of mapped out a circle here. And that's why A and A fourth prime map to the same place. Again, 90 more degrees, A fifth prime would map to A prime, and so forth. All right, let's try a different one. I don't know if it's going to let me erase all this. Probably not, maybe. All right, let's try rotating A 180 degrees by that rule chart over there. Come on, buddy. Oh, it stops there. Okay. So we're going to get rid of this. And now we're saying rotate 180 degrees about the origin, or O for the origin, point A. And here's my point A. Now let's flip over to my PowerPoint. 180 degrees rotation is just negate your X and your Y. So this is -2, -1. So now if I go -2, -1, this happens to be the exact same point I had earlier. If I did it another 180 degrees, I just negate them again. Let's go new color. That's 2, 1. Well, 2, 1 just happens to be here as well. So if we just keep rotating this 180 degrees, it's just going to bounce back and forth. My next instance would then be, and we can just see it's cyclical. Here's where I started, that's where I went, that's where I went. It's just going to keep going in circles. This is going to be my A triple prime. Let's look at doing 270 now. R 270 degrees around the origin. And you don't have to do this on the origin, it's just looks a little easier to show you the first time. So I'm rotating A 270 degrees around the origin this time. Starting with A is 2, 1. I'm going to follow the rule, change their order, but this time I'm going to negate the X that I started with. Right? So my Y, my original Y, is going to come over to be my X coordinate. That's what that means. And my original X is going to become my Y, and I'm going to negate it. So my original X was 2. I'm going to negate it and make it my new Y. So let's see if I did it right. Started with X, Y. X was 2. I brought it over and made it negative, so I do have -2. And then my Y was 1. And I swapped it over to where my X goes, right? So let's see if that looks like it would be the proper thing. So 1, -2. That is A prime. Which brings me to my next point. If I were to have, this looks to me to be a rotation of -90 degrees about O for A. Now, does that make sense? If I rotate 270 degrees positive, I'm going to go through I'm going to go into my second, my third, and into my fourth quadrant, right? Because each quadrant, that's 90 degrees. That's another 90, so that's 180. This is 270. So yeah, 270 should take me from the first to the fourth. -90, on the other hand, this is the direction the clock goes. Is that going to give me this A prime? Well, one way to think about it is, if I were to do a positive 270, right? Or if I subtract 360 from it and I get -90, that should give me the same answer. Do we have a rule for negative rotation though? We do not. So what we need to be able to do is convert this back and forth. So if you have, as we've already said a bunch, negative 180, use the 180 rule. If you have 270, if you have negative 90, use the 270 rule. And if you have negative 270, you're going to use the 90 rule. All right, that's really important to put in there as well. All right. This, when we get to it, is going to be on your participation sheet, so I know that you're kind of following along and able to rotate these. This is a positive rotation. These are all for positive rotation, so make sure you match your rotation. Don't worry about that. And you're going to rotate all 4 of these points and then reconstruct this quadrilateral. I'll give 2 bonus points if you try and name this quadrilateral. Is it a square? Is it a rectangle? Obviously they're not, but I'm trying to get you into the type of answer that I'm looking for. All right. Uh-oh. Oh, I did it for you. So that's what it would look like. So let's do this. Instead of the 90, go ahead and make this a 180 degree rotation. Here's the rule for 90. Go ahead and change this to 180 and take my pre-image here and rotate it 180 degrees. All right. Like I showed earlier, rotations are compositions of reflections. And here's a proof for it. I know most of you are now going to skip this proof, but really just pause it for a minute, read over this, see if you understand it, and let me know in your participation if you understand it. Here's a summary. Now this is not, we skipped this part. Had I been there today, we definitely would have attempted it, and we would have been frustrated with it, I'm sure, because this is very difficult to get while you're learning to rotate. Concentrate on your coordinate plane, and then after topic 11, before your ELC, we'll actually go into depth with constructions. I wanted to show you one other thing, but I don't need the PowerPoint anymore. So really quick, let's talk about why counterclockwise is a positive rotation, and kind of like I said a few minutes ago, some of this other stuff. Please let me delete all this. Puts it right back. Okay, so we all know this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Now if I look at this, 1 plus 1 more, or 190 degree turn, because this whole quadrant is 90 degrees, right? So to go from 1 to 2, I add 1. To go from 2 to 3, I add 1. To go 3 to 4, I have to add. So if you look at it this way, and you think of your quadrants, this shows positive rotation, right? My quadrants increase in this rotational direction. If I look at it the other way, to go from 4 to 3, I'm subtracting. To go from 3 to 2, I'm subtracting. And to go from 2 to 1, I'm subtracting. Now, this one might lose a little bit of its power, but if I'm in quadrant 1 and I go a negative 90 degrees, don't I end up in quadrant 4? So that kind of falls apart at first, but if you think about it in terms of adding or subtracting 90 degrees, it makes it much easier to see which quadrant you will eventually land in. What was the other thing I wanted to say? Oh, now that we're done with the presentation, if you have any questions, add them to the bottom of this video, and go ahead and jump into the homework. If you finish the homework, read over the topic 2 writing assignment, or start your topic 2 vocab. Yes, I'm aware of that. Start your writing 2 quarter 2 writing assignment, or jump into your vocab for quarter 2. I'll be back on Monday.